Don't forget to subscribe and ring that bell.
Hey, you crazies. Just crazy enough to watch the first and second video and pop in here for the third video of the January 2024 exam. Multiple choice problems number 17 through 24. Let's go. And just a gentle reminder, there are only 24 questions in multiple choice, and we are going to finish the last, 8 problems or so. They're 2 credits each. You either get 2 credits or 2 points or nothing at all. No partial credits awarded for any of these. All right, let's do this. Okay, I think we start with kind of a no-brainer. Number 17 says, which equation does not represent an identity, which means which one of these isn't true? First of all, shame on you if you don't recognize that this is a DOPS, a difference of perfect squares, where I use the same 2 terms and there's a plus and minus between them. This is definitely true. Remember, I want the false one. Which one does not represent? The second one, whenever I have x minus y squared, that's not x squared minus y squared. I can't just distribute the exponent. I literally take, when I square something, I literally take that thing and multiply it times itself. So if I have x minus y squared, that's literally, kids, x minus y times x minus y. That's true. That's what they gave us. All right? Now, again, if I square something, I got to take x plus y and multiply it times itself. Okay? If I do that, I get x squared. That's x times y. And then we have another x times y. And finally, a y squared. This here is 1xy and 1xy. 1 and 1 gives me 2xy's. Plus my y squared in the back, and I have my x squared out front. That's exactly what they give us. Ding, 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 ding. Winner, winner, lobster dinner. It's true, but it's not our answer. The last one, by default, has to be false. How come? If I take x plus y and multiply it times itself 3 times, well, I just did this. Here's the answer. It's x squared plus 2xy plus y squared. I still got to multiply that times another x plus y. If I FOIL this, I'm going to multiply each term times an x. So I get x cubed plus 2x squared y plus y squared. And I got to do the same thing with the y's. Okay, now I get x squared y plus 2 xy squared, and then plus y cubed. So when everything's all said and done, I feel like I missed. Oh, this one should be x times y squared is xy squared. All right, and these line up. I have an x cubed. I have 2x squared y and 1x squared y. That's plus 3x squared y. All right. Then I also have 1xy squared and 2xy squared. So it gives me 3xy squared plus my y cubed. So if I do that 3 times, that's really, it's not this. Okay, it definitely isn't that. You didn't have to show that work. If you can prove the first 3 are true, by default, you circle the last one. But some people ask, why is that the answer? And I just showed you. Number 18 gives you what I like to call a whole bunch of poop that you really don't need. But let's go through it anyways. 2 surveys were conducted to estimate the proportion of teens who use social media at least once per day. All right, so we see on the left here 100 samples of 5 teens. All right. And then we look at the one on the right here, and the only thing that's different is now it's 50 teens per sample. Okay, and that's on this one right here. Boom. All right. So There's really two ways we can answer this question, and I'm not even going to get into the details of these graphs, but it says based on these results, it is determined that approximately 75% of teens use social media at least once per day. What is the best explanation for the difference in the results between the two surveys? Notice it mentions in each one of these responses smaller sample size, smaller margin of error, okay, smaller sample size, bigger margin of error, and then it says that should provide more accurate estimates. I'm sorry, I didn't get this other. Should provide more accurate estimates. Then we got a larger sample size is a smaller margin of error, which should provide more accurate estimates. And then the larger sample size is a bigger margin of error, which should provide more accurate. So all of these are saying, they talk about the sample size. Each one of these responses talks about the sample size and the margin of error, whether it's a bigger or smaller margin of error. They all say whatever that first part is, it's going to be more accurate, more accurate, more accurate, more accurate. A rule of thumb is the more people that you ask in your sample size, the larger your sample size is, the smaller your margin of error is going to be. And that will give you more accurate results. The more people you ask, the less chance for error you're going to get. That's choice 3. Now, if someone's like, I need that explanation, Visca, I need the explanation, Visca, 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 Visca. Oh my God. But I'm going to explain it to you anyways. Margin of error. Okay, I talk about the 95% moneymaker a lot. That is your mean plus or minus 2 times your standard deviation. This right here is often considered the margin of error. Okay, notice the standard deviation here is much smaller than this one. If I multiply this times 2, I'm going to get a smaller value than if I multiply this times 2. Okay, so this will be a less or a smaller margin of error, and it should be, you're asking 50 teens, not just 5. Okay, so I come down here, the larger sample size, smaller margin of error. I mean, I don't even have to look at the rest. It's the only thing that puts those two together. And now you know why. Simple algebra problem. Let's go. 19. Given f of x is x cubed minus 3, and f negative 1 of x, this is inverse. This is the inverse of f right here, is the cubed root of x minus 3b. The value of b is what? All right. In order to find the inverse of something, I need to switch all my x's to y's and vice versa. So switch x's and y's. And then I just solve for y again, wherever your new y ends up. So I'm going to take a look at this and find out what the inverse is, and then I'm going to compare it to what they gave me. All right? So you might be saying, Visca, I don't even see a y. Remember, f of x is y. So all I need to do is every y becomes an x. And every x becomes a y. So I just did this first part. Check. Now I just got to solve for y again. All right, well, let's start by, how about we add 3 to both sides? X plus 3 equals y cubed. Well, how do I undo a cube? I know. Why don't we do a cubed root, kids? There you go. So bang, bang, bang. So now y equals the cubed root of x plus 3. That's the same thing as saying the inverse of f, okay? Because that's what we just solved. So if they tell us the inverse of x in this problem they give us is the cubed root of x minus 3 times whatever b is, okay? And we came up with this. Well, let's take a look. That means in order to find out what b is, I got to see what I end up with. Notice, and this is where the trick comes in. Notice my term after the x is a positive 3. That's going to equal whatever they have here, the minus sign, negative 3b. So if I divide both sides by -3, positive divided by, it's -1 equals b. Okay, so that's choice 2. Now keep in mind, if I take what they gave me and I made b -1, so I've got the cubed root of x minus 3 times, now I'm going to put a -1 in for that b. What is a -3 times a -1? It turns to +3. And that's exactly what our answer is. There you go. The number of students that buckle when they see number 20, because there's an equation with an R and a P and an I, and oh my God, we're going to do this. This is just one of those problems where they give you all the numbers for the letters or variables, and you just put them in. There's one little hook here, though. Robert is buying a car that costs $22,000. After a down payment, of $4,000, he borrows the remainder from the bank, a 6-year loan at 6.24% annual interest rate. The following formula can be used to calculate his monthly loan payment. So they give us this equation. I'm going to skip down to the bottom here and say Robert's monthly payment will be. So I need to find the monthly payment. R is the monthly payment. So this is what I don't know. I should be given everything else. Okay? The loan amount is P. So the loan amount is P. All right? What else do we have? The monthly interest rate. It's I. It happens to be in 2 spots, there and there. And then, of course, last but not least, let's go. Orange is nice. T is my time in months. That just shows up in one place right there. It's a negative exponent. All right, well, let's start putting in what we know. P is the loan amount. Now, the car cost 22 grand, but he put down 4 grand. So out of the 22,000, he already put down 4 grand. He borrowed the rest from the bank. That means it's an $18,000 loan. Okay, because it states here he borrows the rest from the bank. So my loan amount is 18 grand. So I start with that. Times my interest rate. Okay, here's where you got to be careful. They give me an annual interest rate. I want a monthly. So I take my interest rate. First of all, I want to get rid of that percent. So I slide the decimal over 2 to the left, or I can divide by 100. That's 0.0624. That's the monthly interest. That's the interest rate for the year. That's what annual means, per year. But they want it months, so I just divide that by 12. That's going to be my I. 0.0624 over 12. Okay? Now, on the bottom, I have 1 minus 1 plus that same monthly interest rate. So it's the same thing. 0.0624 over 12. And last but not least, my number of months. It's 6 years. In 6 years, that's 72 months. Because 6 times 12, 12 months a year, 72 months total in 6 years. So it's negative 72. Keep in mind, my time should be negative, the exponent. I just put that in the calculator and enter. Okay? So what was the trick? This right here is where we might get tripped up. You also got to know, read the problem. You're not borrowing 22,000. That's how much it was. He put 4,000 down. So the borrow was 18,000. Okay, those I think are the two. Every time I start a new video, the little wheel of death, but there it is. Come on. Here we go. So let's go ahead. I'm going to create a fraction. And in the top, I'm going to put my 18,000 times another fraction. And this fraction here is 0.0624 over 12. That was my I value. Over. All right? 1 minus, parenthesis, 1 plus. That's kind of weird, but we'll work with it. Who cares? And then it's the interest rate again. It's another fraction. You can put fractions and fractions. Of course you can. You can put fractions and fractions and fractions and fractions if you really wanted to. But, you know, we're not going to go crazy. We're going to raise that to the negative. Don't hit the minus sign, hit the negative. 72 for 72 months. $300, and we'll round that up to 36 cents. Choice 2. Okay, now in my class, we really don't stress secant and cosecant and cotangent too much. We really don't stress too much tangent. We do, a little. But for the amount of material I got to teach, there's some things that I got to kind of strip away, and this is one of them. So let's pay attention, shall we? All right, so they tell me, if the tangent of theta is negative 4/3, okay, where theta, my degree here, is between pi over 2, which is 90, and pi, which is 180. Between 90 and 180. Okay, what's the secant of theta? Well, first of all, let's establish a couple of things. If I have a unit circle, okay, and I start here's 0 degrees, here's 90, and here's 180. My angle should be between 90 and 180. So if I start the angle here, and I end it somewhere in between, I'm just drawing this. This is theta. That's angle theta. The tangent of theta, okay, the tangent of theta is negative 4/3. Now, why did I draw this? Because all students take, we'll go with cookies today. I'm in a sugary little mood. Anyways, sine is the only positive function in this quadrant. That means cosine and tangent are both negative. And that's true because my answer is negative 4/3, and it's tangent. Tangent's negative. So what I do is I just draw this little triangle here. I have a right triangle. This is my reference angle. Tangent is opposite over adjacent. Okay, OP for opposite. That's not a 0. So the opposite should be my 4, and that's negative 4/3. The opposite should be the 4. So if my angle, this is opposite, so this side is 4. Adjacent should be 3. Adjacent is 3. Here's adjacent. So I don't know what my hypotenuse is, okay? Hopefully some of you can realize that, well, I have a Pythagorean triple. What does that mean? If I have one leg that's 3 and one leg that's 4, my hypotenuse is absolutely 5. This guy didn't know that. Then use the Pythagorean theorem. 3 squared plus 4 squared is going to give me whatever my hypotenuse is squared. 9 plus 16, that's 25, is my hypotenuse squared. That means if I take the square root of both, my hypotenuse has to be 5. Okay, so you can do it that way. Secant. Secant is the reciprocal function of cosine. So if I know cosine of something, okay, that means secant is 1 over the cosine of theta. Or, if I really want to, cosine is adjacent over hypotenuse. Secant is the flip of that. It would be hypotenuse over adjacent. So I could do it either way. I think since I have the triangle, this is easier. Okay, so I'm looking at my angle here. Opposite, or excuse me, ha, 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 ha. Get it? Ha, H over A? Yeah, I know, that was stupid. Hypotenuse over adjacent. So it is 5/3. And since cosine is negative in that quadrant, so is secant. All I do is I flip the fraction. It still keeps the same sign, so it should still be negative. That was it's a lot of detail to know. All right, but you know what? It's the right answer, choice 1, and we're done. With problem 21. We still have 3 more problems left to go. Okay, buckle up. We're going to do some algebra. I mean, I could try and graph this, but we'll get there in a second. To solve the equation, 7 over x plus 7 plus 4x over x minus 7 equals 3x plus 7 over x minus 7. Jones' first step is to multiply both sides by the least common denominator. Which statement is true? All right, I don't care how she solves it. I just got to figure out what this is. Now, if I wanted to, I can add this to both sides because this is the same denominator as this, which means I can combine them. Then I'll have one fraction equal to another, and I can cross multiply, and I can go from there. Or if I want to do what Joan is doing here, all right, I'm going to find a common denominator. Please note, this has an x plus 7. These don't. So these both need an x plus 7. These two have an x minus 7, so this one needs an x minus 7. Okay, so that's what I'm going to end up doing. This needs an x minus 7. What I do to the bottom, I need to do to the top. This needs an x plus 7. What I do to the bottom, I need to do to the top. And this also needs an x plus 7. What I do to the bottom, I do to the top. Now, once the bottoms are all the same, I'm just going to cross those out. So, distribute 7x minus 49. 7x minus 49. Plus, I distribute the 4x. It's 4x squared plus 28x. 4x squared plus 28x equals, oh my god, I gotta FOIL this. 3x squared plus 21x plus 7x plus 49. These two combine to be 28x. So I've got 3x squared plus 28x plus 49. I got to get everything to one side. Okay, it's going to be quadratic. It's going to be messy, but, you know, we like messy, right? I'm going to subtract 3x squared. Subtract 3x squared. So this gives me 1x squared. Then I'm going to subtract 28x from this side. Subtract 28x from this side. This is gone. So I really only have a plus 7x left. And then I'm going to subtract 49 and subtract 49. Those don't cancel on the left side. A negative and negative is a bigger negative. 98 equals 0. All right. Booty, cheek, and T-bone. Da, 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 da. Now, in case you don't know this, okay? In case you don't know this, you can go on your calculator. Oh, man, I'll show you. I need two things that need to multiply to negative 98, but they need to add to positive 7. So if you're not good with factoring, I can go right in my calculator, and I want to take the number that I want to get the factors of, negative 98, and divide it by x. If I look at the table, okay, if I look at my table, 1 times negative 98, isn't it? 2 times negative 49. 3, and this is a decimal, so it doesn't go any, so this is not a factor. They got to both be whole numbers. 4 isn't a factor, 5, 6 isn't, 7 is, because 7 and negative 14. In fact, oh, I swear I hit that. What is up with that? Okay. In fact, when I look at this, if I take 7 and 14, okay, if I use negative 14 and positive 7, that will give me a negative 7 if I add them together. But what happens if I switch the signs? What if I make my 7 negative and my 14 positive? It will still multiply to be negative 98, but now it gives me a positive 7, which is what I want. So I'm going to use a negative 7 and a positive 14. And when I solve for those, x would equal 7 and x will equal negative 14. So the problem is, which statement is true? You might say, oh, look, there are no extraneous. But what does extraneous mean? That means you solved for it, but it doesn't quite work. The only thing that can make a fraction not work is if the denominator is 0. If I put a 14, a negative 14, into any of those denominators, I get a number. But what happens if I put a positive 7 here or here? Isn't positive 7 minus 7 0? This will not work. It will make my fractions undefined, and my problem won't work. So 7 is extraneous. 7 is an extraneous solution. Goodness gracious. Now, why didn't I graph this from the beginning? Because if I graph this, it won't cross. It won't intersect at 7. Okay, so you don't know what answer won't work because it won't cross there. And you can maybe figure it out through trial and error and just kind of based on what information they give you in the multiple choice. But you should know how to do this algebraically anyways. Number 23, beginning July 1st, 2019, Michelle deposits $250 into an account that yields 0.15% each month. She continued to make $250 deposits into this account for the first of each month for 3 years. Which expression represents the amount of money that was in the account after her last deposit was made? You have got to add up all these deposits, which means you're doing some sort of series. This is a geometric series because it doesn't go up by the same amount every time because the percent, you've got to multiply it times a ratio, okay? Or a rate, all right? So on your reference sheet is this little nugget right here. My total, whatever it is my first term. That's what A of 1 represents. Minus the first term times the rate, okay, times n. Okay, and n, in this case, is going to be our number of occurrences or months. See, she is depositing this money each month for 3 years. So right now, 3 years, there's 12 months per year. That means my n is 36. All right? And it's over 1 minus the rate. Now, in this problem, my r is the 1 plus or minus the r. Okay, it's 1 plus or minus the r. I know they have an r here, and then you do this. It's almost like the b value in exponentials. You get a times b to the x, right? And growth and decay. And it's 1 plus or minus r that's in this b. So when I look at this equation, my r is actually 1 plus or minus the rate they give me. All right? Don't make that mistake. I hate that they do that, but that's just how it is. So let's set up this equation. My first term, well, she starts by putting in 250. So that's A1 minus, okay, I do 250 again. Then I get 1. This is going up. Okay, it's going up 0.15%. 0.15%. I want to get rid of the percent. I got to divide that by 100. Or slide the decimal over twice. So that's what it is. So in here is 1 plus 0.0015 or 1.0015. There you go. Okay. Let's now put this to the r, which is 36. It's 36 months over 1 minus 1.0015. And I mean, it's right there. You just got to know to go on the reference sheet, convert your percent by dividing it by 100, and that your months, you don't put 3 there for years. This is monthly. She's depositing every month. You're adding that up. That's 36 months. One more problem. Kids, I really hate redundancy. I hate doing something, then doing it again, and doing it back again. It's killer. And that's what this problem does to you. It's not a big deal. It's not a lot of work at all. A study of the red-tailed hawk population in a given area shows the population h of t can be represented by the function h of t equals 50 times 1.19 raised to the t. Last problem, we just talked about ab to the t, well, to the x, we called it, where this is 1 plus or minus our r. And how funny this problem is that. Here's your a, which is your initial value. This is 1 plus your rate. Okay? So we literally just talked about that right here. Funny, the foreshadowing, they call that in the film industry, children. Okay, where t represents the number of years since the study began. In the terms of monthly growth rate, the population can be best approximated by which function? So I've got to take 50 and multiply it times by 1.19 raised to the t. Keep in mind, this is 1 year. Time equals 1 year. Okay? They want it in months. So a year is 12 months, isn't it? If I want it in months, okay, I want it to be 1 month. Don't I got to take 12 and divide it by 12 to make 1 month? Which means I take my year and I divide it by 12, which is like I take my time, which is my year, and I divide that by 12. So a year divided by 12 is now in months. So my exponent, okay, this is like saying 1t over 12. So I got 50 times 1.19, 1/12 of a year is a month. But now I want to, the interest rate isn't going to be the same. I got to do it in months. Well, in this case, I guess it would be population growth or decay. I take that 1/12 and I actually apply it to this. So in my calculator, because I just want the exponent to be the variable, okay? So I'm going to take 1.19 and raise that to the 1 divided by 12. 1.0146. Oh, they only go 2 decimal places. So we'll call that, we'll go 3 places. It's now 50 times 1.01. It was 46, so that will be a 5. T. This is now in months. But if you were here at the beginning of this problem, you know I hate redundancy. That's not an answer here, okay? So they want to represent my annual, which is this, but they wanted the monthly growth rate. This 1 plus r, this is now monthly. We applied that 1/12 to it, right? We applied the 1/12 to it. This is now monthly. But they still want the annual. They want the annual exponent, but with a monthly rate. We have the monthly rate, but now my exponent is now months. How many months are in a year? 12. So in order to make this 1 month back into 1 year, I got to multiply it times 12. So my 1 year is 12 months. Okay? This t is in months right now. So how do I make that into year? 12 times the month is now a year. I think it would have been easier for you to understand. This is now in months. We converted it when we put the 1/12. And I want that to years to bring it back to the t years. Well, 12 months is 1 year, right? So the exponent I'll just change back to a t. It's just, you see how we changed it to months by dividing it by 12? Now we're multiplying it by 12 again. And this is 50, not 5. That's the redundancy that I dislike. The people who write this test are no longer testing you on your math skills, but like on trying to not be tricked, which I can't. I'm going to use the word frickin'. I can't frickin' stand. We are done. We've been here 33 minutes. Multiple choice is done, man. Have a good day.
Don't forget to subscribe and ring that bell.